So for this second session, we have the discussion about another fluid flow measurement with it, which is the weir. Ayan. Ito yung weir natin. Lang natin. Ayan. So yung weirs natin, so as you can see, it is a plate na may mga butas and we have this varying or we have this different classification na by shape. So ito rectangular, yung nakikita nyo, yung malaki. Then yung isa naman is a triangular. This triangular weir is also known as a V-notch. Sa letter V. Yeah, V-notch weir. Ayan. So how are these weir used to calculate or to regulate the flow? So discuss natin. So, weirs are overflow structures which are built across an open channel for the purpose of measuring or controlling the flow of the liquids. So, unlike sa ano natin sa mga venturimeter and orifice meter, kita nyo kanina doon sa figure. So, sila, ina-apply sila sa mga pipelines, di ba? Itong weirs, they are used for the open channels. Well, meron din naman tayong orifice for open channel, di ba? Nasabi ko kanina, na mukha siyang plate, tapos may butas lang na bilog. Now, weirs, we have this open channel na part ng ating reservoir. Yung dinadaluyan ng liquid natin papunta doon sa mga distributing na portions ng mga locations natin, o stations. Yan. So we have different, actually, na different na cross-section ng mga open channels. So meron tayong rectangular, may trapezoidal, may triangular, meron ding semicircle. But for this sample ng open channel, we have a rectangular. So, in this open channel, syempre, may nagpo-flow dyan na liquid from the upstream, kung saan nanggagaling yung mga liquid natin. So, bababa yan dyan. And we use weirs to measure or to control the flow. So, ini-install natin yan dito. So, let's say, we have a triangular weir. So, i-install yan dyan siya. Ayan. So, ang tendency sa liquid natin, kung initially mababa lang talaga siya, ganyan, mababa lang yung liquid natin dyan, initially yung nagpo-flow, kapag mayroon tayong weir, pag may weir tayo, syempre kung mababa, magkakaroon yan ng dagdag na head. So, aangat yan, aangat hanggang sa mag-overflow yung liquid natin dito sa ating weir. So, aangat yan dyan, na matatapon yung liquid. Ayan. So, hanggang maging stable na yung ating uh, water surface. So, let's say we have a water na liquid na nagpo-flow dyan. So, hanggang maging stable siya at this height. So, yung surface level natin hanggang sa crest. So, we call this as the crest ng mga weirs natin. So, that height is what we call the head. No? Head of water sa ating weirs. So, we use this head ng water to calculate for the Q. So, may kinalaman sa head niya. Yung, ano natin, yung mga solutions dito sa weirs. Ayan. So, hindi lang naman isang weir yung ini-install natin kada open channel. Kasi, syempre, di ba, yung open channels, mahaba yan. So, we can apply or install a lot of weirs. Pwedeng meron ka pang 3 kasunod dito sa unahan, pwedeng 5. Ayan. So, for you to have different results ng Q, tapos ma-compare mo sila and you have this graph and you will have the result of an actual value of Q, no, by series of experimentation by putting a lot of weirs doon sa iyong channel. Okay? So, sabi ko nga, meron tayong iba't ibang classification of weir depende sa kanyang shape. Yeah. So, according to shape, we have these 5 shapes of weirs: rectangular, triangular, circular, parabolic, and trapezoidal weirs. But most commonly here in hydraulics, we have rectangular, triangular, and the trapezoidal weirs. Yan yung mga isosolve natin dito ng mga weirs or i-investigate. Okay? And we also have this classification according to the crest. Yan. According to the crest, no, itong sa type ng weir natin. So, itong sample na to is part of crest natin na sharp-crested. Yeah, so we have sharp-crested weir, broad-crested, narrow-crested, and OG-shaped weir. So, discuss natin tong dalawa, the sharp-crested and the broad-crested. The sharp-crested weir are the weirs na plate lang. So, plate. So, ito yung sample natin. Yung nakita nyo initially na drawing or figure for the weirs, yung plate, yung meron lang siyang ganitong thickness, no, for the plate na talaga sobrang nipis lang. So, that is a sharp-crested weir. Ayan. Then, for the broad-crested na weir naman, meron na siyang depth na kitang-kita mo na. So, let's draw for the broad-crested weir. So, the broad-crested weir is in this position. So, I will draw the isometric drawing. Yeah, so, mas makapal siya kasi sa sharp-crested na weir. Yeah. So, this would be its isometric drawing or 3D na figure. Ayan. So, ganyan yung tsura niya. So, parang bakal yan. Bakal siya na may level na mas mababa kaysa dito sa may sharp-crested na weir kasi matataas yan eh. Nasakop niya yung isang open channel. Plus, ito naman, mababa siya at a certain distance lang or certain height. So, draw natin siya kung paano inilalagay sa open channel. Let's say this is the length of the channel.
Sir, sabi kanina sa meeting, ano din, kailangan natin din for yung student?
Ayan, so ilalagay siya somewhere here. Sa loob.
Dapat maaga silang, kailangan pa natin i-announce sa room natin.
Ayan, and may certain height lang siya dyan.
Sa student.
Mga harang yan. Ayan, so burahin natin yung mga unimportant lines para maging mas totoo yung drawing natin. Ayan siya. Ayan siya. Yan yung drawing natin for the open channel and the broad-crested weir. So, mangyayari niyan kung initially bababa lang yung liquid mo dito, yung daloy niya, nung wala pang weir, may ipon yan hanggang sa mag-overflow siya yung liquid natin. Then, dadaloy yan pababa, tapos yan, mag-overflow. So, ganun din, na meron din siyang head dyan na nasusukat dito. Yung head ng liquid natin, tapos hanggang sa mag-flow na siya dyan pababa. So, mga barriers, kumbaga, yung mga weirs natin. Okay? So, kung gusto nyo makakita ng actual na figure nitong sharp-crested and broad-crested weirs natin, meron akong papakita sa inyong video. Which is, makikita nyo rin naman sa experiment natin.
Because the grade consultation, set ko siya sa private, sa Corrento. Kaya yung konto naman siguro ng mga grade case.
Materials, eh. Kasi yeah, so this would be a sample of a broad-crested weir.
Apo.
Ayan. So, makikita nyo to sa topic pa natin na hydraulic jump. Ayan. So, ayan yung ating weir. The broad-crested. Barrier siya dyan. So, ito yung head natin, no, from this hanggang dyan. So, dito kasi nagkaroon na ng curvature yung liquid natin, no, pababa na kasi siya. Ayan.
Hindi ba sa thank you?
Okay.
Sige po, thank you.
Then for the sharp crested naman, panoorin nyo to. Pwede nyo naman panoorin. For hydraulic jump lang naman yan. Habang hinahanap ko
Experience.
yung ano.
May picture na ako nun, ay may video na ako nito eh.
Ayan. So ito, sluice gate yan. Tapos for ano pa naman to, matagal pa natin topic, which is the hydraulic jump. Yung pinapa-jump natin yung mga liquids. Ayan. So, dyan siya in-apply. Right after the sluice gate, we have the weir na broad-crested. Okay. Ayan. So, ito naman yung sharp-crested weir. So, plate lang talaga siya dyan. And meron tayong nag-overflow na liquid. Yeah. So, yung channel natin here is yung path ng liquid dyan. So, yung open channel. Tapos, ganito siya ini-install by mga tornilyo, mga screws. Okay. Yung broad-crested, pinapatong lang siya doon sa ating open channel. Ayan. So, sample of a sharp-crested weir and broad-crested weir. So, na-visualize nyo na sila. So, dagdagan pa natin yung mga classification of, ng weir natin. So, according to the discharge condition. So, according to the discharge condition, nakita na rin natin to sa orifice, di ba? So, we have the free flow discharge, and meron din tayong submerged flow. So, kailan tayo nagkakaroon ng free flow? So, yun. Pag ganito, yung nagpa-flow lang, wala tayong pinupuno na tawag dito na another channel, gano'n. So, hindi submerge yung iyong weirs. No? Ganyan lang siya. At the second or dito banda sa may downstream natin, hindi tumatama yung liquid sa ating weirs or hindi punong-puno. No? So, kapag submerge, let's draw the side view. So, let's say we have the channel bed. Ito yung channel bed natin. And we have our weir there. Then, this is a weir na rectangular na buong width natin meron rectangular lang talaga na wala siyang butas. So, ang nangyayari, we have a liquid coming from the upstream na may head na ganito. So, we have here overflowing. Tapos, syempre, di ba mag-overflow yan, tutuloy yan hanggang sa baba. Then, the liquid at the downstream is at this level talaga siya. So, ito yung totoong level nung sa kabila. So, may nagpo-flow lang sa atin continuous from the upstream papunta sa kabilang side. So, here, in the sample, we have a submerged flow. Nakalubog both sides yung ating weir. Yan. Submerged siya dito sa upstream, submerged din sa downstream. Yan yung mga liquid surface natin. Ayan. Then we also have this classification according to the effects of the sides of the emerging nape. Ayan. So, ano kaya si nape? Ayan. Na para ma-discuss natin kung ano si nape, let's take a look with the side view ng weir natin and yung sa mga liquid surfaces natin. Pakita natin yung mga parts. Yeah. Ayan. So, we have our flow ng liquid from this side, from left to right. So, number one, we have the weir plate. Ito yung weir plate natin. Yung number two naman daw, yun yung crest. Crest. So, dito, pag titignan natin yung front view niyan, we have this channel. So, yung channel natin. Then, yung weir natin is a full width weir na rectangular. Ayan, so rectangular ganyan. Buong channel lang natin meron. So, wala siyang butas na gano'n. Okay? So, yan siya. Pag tinignan mo sa harap, sa front. Then, ito yung crest. Ayan, crest. Then, we have the approach. Yung approach natin is yung point kung saan wala pa tayong weir. No, bago magkaroon ng weir. Wherein, yung depth ng liquid natin is yung H plus P. H plus P. Yung head na kung saan hindi na nagbabago yung head mo, hindi na umaangat pa, hindi na tumataas or bumababa. Yan, so, dito kasi at point na meron na tayong weir, nagkakaroon na ng pagbaba or draw down or drop down at point wherein we have the weir. So yung H and P natin dyan is kompleto pa. Yan. So P is the height of our weir plate. So, at our approach, no, kinakalculate din natin yung velocity there, no, yung velocity of approach. So, recall lang natin yung equation natin for the velocity. So, it will come from the Q. No, Q is equal to V times the area. Okay, yung Q natin is yung Q na mami-measure ng weir natin. And it must be equal to the velocity ng approach. Ayan. And ano yung area? Yung area natin is yung cross-sectional area ng ating liquid. So, we have this height na H plus P or D. Yan yung depth of our upstream na tinatawag. D times the length nung ating channel. So, yung area natin is depth ng upstream times the length of the channel. So, that is how you will relate yung Q mo and yung mga distances ng P and H length with the velocity of approach. So, yan yung velocity mo bago ka magkaroon ng weirs. So, iba yung value ng velocity of approach mo kaysa doon sa value of the velocity before or after the weir or doon sa weir natin directly. Okay, kasi nagbabari na yung cross-sectional area natin dyan. So, di ba, nagkakaroon ng drawdown. Di ba, lumiliit yung ating cross-sectional area. Ayan. So, yan yung sa ating velocity of approach or the approach. Now, nape. Ano yung nape? Yung nape natin is yung pagkakaroon ng curvature or pagbaba yung ating liquid. O yung kapag dumaan na siya sa weir. So, ito yung part na yon. Yan. Yung bumaba siya. Yung nagkaroon ng curvature dyan, pagbaba. Nape. Ayan. So, we have this according to the effects of the sides of the emerging nape. So, we have a contracted weir and suppressed weir. So, actually, this contracted and suppressed weir, para lang siya sa isang rectangular weir. Yan. Under siya sa rectangular type natin ng weir. So, kanina, pinakita ko yung isang weir na tuloy-tuloy lang, yung full width lang. Yan yung itsura niya. So, this weir is what we call the suppressed. Suppressed na weir. So, iba yung magiging effect niya, no, magiging effect ng suppressed weir natin sa pag-calculate ng Q kaysa dito sa may contracted no weir. So, may iba't iba tong mga equations na ginagamit. So, when we say contracted no weir, we have sides pa dito. So, drawing natin, we have ganitong type ng contracted weir, wherein may isa lang siyang leg. Yung isa naman, magkabilaan. So, pareho naman to na contracted weir. Ayan. So, for this figure na nasa taas, that is a singly contracted. Yeah, contracted weir. Yung nasa baba naman is a doubly contracted weir. So, singly and doubly. Now, sa mga problems, paano mo malalaman kung singly or doubly siya? Kasi nga, may mga contracted weir tayo na nakikita sa problem. Sa problem, pag hindi binanggit na singly or doubly na agad yon. So, let's say, a rectangular contracted weir, so doubly na yon. Ganon. Pero pag sinabing a singly contracted weir, so singly na. Yun lang naman yung magiging hint ninyo sa problems kung anong type siya ng rectangular weir, kung contracted ba or basta pag binanggit na contracted, doubly na yon. No, hindi mo na kailangang alamin kung ah, isa lang ba or dalawa. No, kasi dalawa na agad kapag end contracted or end contractions. Well, mamaya pakita natin sa mga props iba't ibang variation niya. Or hindi, sige, dito na lang pala. So, doubly kapag binanggit na end contractions. Sulat ko na, no? So, a rectangular weir with end contractions. Yun yung mga hint ninyo. So, kapag nakabasa nyo to, ay rectangular weir with end contractions, doubly na agad yun. And also, kapag sinabing a contracted rectangular weir, yan. Whereas, kapag ka-singly, babanggitin talaga na singly. No, single contracted, gano'n. Ayan. So, pag hindi kayo binigyan kung singly or doubly na yan siya agad. Then, for the suppressed, sasabihin din niya kung suppressed siya. So, rectangular suppressed weir. Okay? Ayan. So, yan lang naman about the classifications of our weirs. Balik tayo. Yan na naman yun. So, we can now proceed to the equations used to calculate the flow rate in our weirs. Marami to by different na shape. Kapag ka rectangular, may mga nakalista tayong equations for Q, with different conditions pa din, kung approaching ba the velocity of approach or not considering or neglecting. Ayan, then for triangular, pag triangular na yung weir natin, may iba pa rin niyang equation. And also kapag trapezoidal. And also kapag free flow or submerged flow tayo. Ayan, so may mga equation tayo for that. And also kapag kinonsider natin yung sides natin, kung contracted or suppressed. Sige. So, simulan natin yung paglista sa mga equations natin for the weir. And again, these equations are not, hindi sila nade-derive because they are empirical formulas. Na-derive sila from a series of experiments. Ayan. So, magkakabisado tayo dito ng mga formula. So, for your reference, these are the variables for the equations na makikita nyo dyan. Okay? So, for a rectangular weir, so we have to note of this parameter. So, L is the length of the crest ng weir. Yan. And also, pwede rin yung length ng ating channel. We have H. H is the head of our liquid hanggang sa top ng weir or hanggang sa crest. Then P is the height of our weir and D is the depth of water upstream, which is equal to H plus P. Now, for us to calculate the Q in a rectangular weir, we have this equation that considers velocity of approach. So, medyo mahaba siya. We have Q is equal to CWL multiply to H plus HB, quantity raised to 3 halves minus HB raised to 3 halves. Now, that is for considering the velocity of approach. Ayan. So, we have problems that neglects velocity of approach, meaning yung HB dito, which is the velocity head of approach will be equal to 0 na. So, malilesen yung ating equation. So, 0 to 0. Ang matitira sa atin is the CWL H raised to 3 halves. Again, yung H, ayan siya. Ayan. Kailan tayo nagkakaroon ng neglect ng velocity of approach? Kapag yung ratio ng H and P, yung head and the plate, is small. Or binabanggit yan sa mga problems. Sasabihin yan, neglect velocity of approach. Yan. Or, hindi rin binabanggit. Kapag hindi binanggit, rekta na yon sa mga problems, neglect velocity of approach. Ang madalas nga na nilalagyan sa problem na, para ma-define mo na kung consider ba siya or neglecting. Yung word na consider. So, kapag consider velocity of approach, ayan. Pero pag wala, walang nakalagay na hint, so that is neglect agad. So, you will use this equation ng Q, CWL, H raised to 3 halves for rectangular weir. So, for rectangular lang yan. Ayan. So, yung L dito, nagva-vary yan if we have suppressed or we have a contracted the weir. So, we have to solve for the effective length L kapag contracted weir. So, ito yung equation natin for that. We have L prime minus 0.1 NH kapag contracted yung weir sa mga problems. So, wherein L prime is the measured length of the crest. Then, minus 0.1 NH. And here is the number of end contractions. So, 1 kapag singly, yung 2 naman kapag ka doubly. Ayan. Then, H, again, is yung head ng ating liquid hanggang sa top ng ating weirs. So, ito yung gagamitin mo equation kapag contracted weir ka. Yan. Then, CW, nakikita nyo may CW equation natin for the Q. That CW is a weir factor. Ayan. And we have a lot of value for this CW na kinakabisado. Yeah. So, unang-una dyan is the standard weir factor CW, which is nagre-require na alam mo yung C, yung coefficient of discharge ng ating weir. Yan, coefficient of discharge. 2/3 C square root ng 2G. Yan. So, may 2/3 tayo dito na value. Ayan. So, isa pa lang yan. Marami pa yan kasunod. We have this contribution of Francis for the CW, which we call the Francis formula. And effective siya for the SI units lang. Na hindi na natin ibibigay yun sa mga English units because yung mga English unit naman na formula is hindi naman lumalabas sa board exam. Para onti na lang yung kakabisaduhin nyo, puro SI na lang tayo. So, standard kasi yung SI. So, CW is equal to 1.84 multiply to the 1 plus 0.26 ng H over D square. Now, this CW is used for this qualification na yung ratio ng H over P must be greater than 0.4. Kailangan ma-achieve mo to para magamit mo yung equation na yan. Paano kapag hindi na-achieve? Paano pag less than? Kapag less than, ito yung value natin ng CW. 1.84 na lang. So, magiging 0 na yun nandyan. Ito, multiplier natin dito na pangalawa. 0. You have CW is equal to 1.84. Kapag less than 0.4. Pero pag greater than, yung H over P natin, yung nasa taas. Okay? So, dapat alam natin kung kailan natin ginagamit yan. Ito nasa taas na weir factor na standard, ginagamit yan kapag given tayo ng C. Pero pag hindi, pupunta tayo dito sa baba. Pababa yan. Marami pa yan. Now, we have now the Reback and Chow formula. For SI units pa rin ito. No, we have CW is equal to 1.8 plus 0.22 multiply to the H plus, divided by P. H natin is the head, P is the height of our weir. Ayan, Reback and Chow. The next, we have the greatest formula of all, the basin formula. Ayan. Ang basin formula natin is itong pagkahaba-haba na yan. So, for CW pa lang yan. Hindi mo pa nakakabisado yung sa Q natin. Ayan. So, CW for basin formula is 0. Nabigyan natin ng zoom. 0.5518 multiply to 3.248 plus 0.02161 divided by H times 1 plus 0.55 H over D squared. So that is the basin formula for Weir factor. So for Weir factor yan. Ayan, dami no? Daming equation for the Weir. Ayan, yan yung sa rectangular Weir natin. Ayan. So let's move on to the triangular Weir naman or our V-notch. Ayan. So, mga important parameters natin dito is H and this angle between the weir is theta. Then, the length naman nung liquid surface natin dyan is L. Ayan. So, we have Q. To solve for the Q, we have this equation. CW tangent theta over 2H raised to 5 halves. So, ito yung equation for a triangular weir. Iba siya kapag sa rectangular. So, ito yung rectangular natin for Q, no? Tapos yung CW is, ito din, yung naiiba. Yan. So, for CW ng triangular, hindi pwede itong mga to. Yan. Kasi for rectangular yan. So, may sariling formula yung CW for a triangular. CW for triangular is 8 over 15 C square root ng 2G. So, dito 2/3. Dito 8 over 15. Ayan. So, ayan lang naman for the CW. And this equation for Q is, ayan, neglecting the velocity of approach. Yung Q natin dyan. Wala naman tayong mga problems ng triangular weir na considering the velocity of approach. Sa rectangular lang siya. Ayan. Then, we have a special weir na triangular, which is a 90-degree weir. So, meaning, yung angle dito ng weir natin is 90. So, meron siyang derived na equation na and for SI units, which is 1.4 H raised to 5 halves. So, may kli lang. 1.4 H raised to 5 at kung kailangan lang, alam mo tong constant na to na 1.4. Okay? Then, next, we have the trapezoidal weir. Yan. So, we have this trapezoidal weir and given these parameters, yung H is the head of our liquid hanggang sa crest. Then, theta is the angle or theta over 2 is yung angle dito na inclination ng sides natin vertically or referred dun sa vertical na line. And we have the length of the crest, yung nasa baba. Ito yung length ng crest, L. Yan. Then, yung total length here would be 2B plus L sa taas. Now, for us to calculate the Q here in our trapezoidal weir, kapag alam mo si rectangular wheel, yung equation for rectangular wheel and triangular weir, malalaman mo din si trapezoidal. Bakit? Kasi pinag-add up lang yung Q ng trapezoid, ng rectangular and ng triangular. Bakit? Kasi di ba meron tayo dito, parang meron tayong rectangular. Tapos itong dalawang to, pinagdikit mo, yan ay triangular. Ayan. So, na-derive itong equation na yan. We have CW1 LH 3 halves plus CW2 ZH 5 over 2. Ma'am, sabi mo pareho sa triangular yung isa kasi pinag-add lang. Bakit nagkaroon ka ng Z? Ayan. So, yung Z kasi dito, in terms of the tangent theta over 2. So, pinaikli lang para wala kang ng kinakabisadong trigonometric functions. Ayan. So, tangent theta over 2, yung Z natin. Or, kung titignan natin yung ating figure for a trapezoidal weir, the tangent theta is equal din daw sa B over H. Paano nangyari? So, zoom natin. So, kuha tayo ng maliit na triangle dyan sa portion ng ating weir. Ito yan. So, our tangent theta is ito. Naka-refer siya sa vertical. Ayan. So, di ba, ang tangent, that is an identity na equal sa opposite over the adjacent. So, yung opposite natin na side would be B, no, from this triangle. And yung adjacent naman natin is H. So, yun nga, no, tangent theta over 2 is equal to B over H. Yung B mo is ito, yung horizontal na line hanggang dyan, no, bago ka magkaroon ng L. Yan. Then yung H mo naman is yung head ng liquid. Yan. So that is the equation. So for CW1 and CW2, just refer to the equations of the Weir factor. Yan lang naman sila. Okay? And like the triangular weir, we have this special na trapezoidal weir, which is we called na Cipolleti weir. Cipolleti, meron silang tawag dito. So, Cipolleti. Ang Cipolleti weir, meron siyang side slope na 1 horizontal and 4 vertical. So, dito yan sa side slope niya. Yan. So, may ratio siya na 1 horizontal, 4 vertical. Or in terms of the angle, na pwede rin kasi makita yung clue sa mga problems is this angle na 75 degree nakalimutan ko, pero 75 degrees. May kasunod yan, naka-minutes and second. So, yan, 57. 57 minutes and 49 seconds. Yan. So, in terms of the angle, yung side slope mo naman is 75 degree, 57 minutes and 49 seconds. So, yun nandito yon. Kasi one horizontal to, ito for vertical. So, sinolve lang natin yung angle ng side slope na to. So, let's say alpha. Yang alpha na yan is equal to this given value na nasulat ko. Yung 75 degree, 57 minutes and 49 seconds. Paano siya nakuha? By tangent lang naman na function. So, di ba, tangent alpha is equal to 4, opposite over the adjacent. Now, solve for the alpha. So arctan lang yan. Ang makukuha niyong value ng alpha is 75.96375653, di ba? So, degrees to. So, pag gusto nyo gawing minutes and second, no, pindutin nyo lang yung katabi nung or yung sa letter B, yung may ganito, degree, tapos may parang kuwit, tapos dalawang kuwit. Ayan, itong symbol na to sa calculators ninyo. Ayan. So, hanapin nyo to. Nandun to sa may letter B. And so, pag kinlik nyo yan, magiging ganito yung form niya. We have 75 degrees, 57 minutes, and 49.52 seconds. Ayan. So, yung iba sa problems, ganito na lang yung ginagawa. 49. Or, ito. Yung mas kompleto. 0.52. Yan yung inclination ng side slope ng ating Cipolleti weir. Yan. So, for that Cipolleti weir, our derived equation is 1.859 LH 3 halves. Yan yung kanyang equation. Yan. So, sabi ko nga, di ba, mga empirical na equations yan. So, if you will investigate for the unit ng Q na madederive here, yung unit ng Q dyan is in cubic meter per seconds. Yeah, ito, cubic meter per seconds, cubic meter per second. So then, cubic meter per second yan. Lahat ito ng nasa SI. So, check nyo yung sa Cipolleti weir natin. And so, for the Sipolati weir, we have this parameter na L and H. So, alam natin na si L is a measurement na meter. Yan. Then, yung head din natin is in meter. So, ito ay naka-raise pa sa 3 halves. So, we have M and M raised to 3 halves. So, kung mag-check ka ng equation mo using the units, wala tayong mapapala. Kasi yung other unit na nawawala dito para maging cubic meter per second siya is nanggaling doon sa mga constant natin. Ayan. So, for Q, yan, basta SI yan, we have in terms of the cubic meter per second. Ayan. So, ang technique dito para makabisado natin yung mga equation na yan is gamitin sa mga problems. Mag-solve ng mga problems. Kapag alam niyo na yan, yung mga equation na yan, direct substitution lang ulit yan sa mga hydraulics na problem natin. If Ayan. So, those Q na binigay dito is for a free-flowing na discharge. Ayan. Free-flowing weir discharge. Now, what if we have a submerged weir? For a submerged weir, we are given by this equation na Qs over Q. Qs is the submerged Q. Then, multiply to the 1 minus H2 over H1 raised to N. Then, quantity 0.385 na raised to 0.385. Wherein, H2 is the final head. Then, H1 is the initial head. Then, yung N naman natin, nagba-vary siya depende kung anong weir yung gamit natin. We have rectangular weir and triangular weir. So, kapag rectangular, 3 halves yan, yung N natin. Kapag triangular, 5 halves naman. Ayan. So, for a submerged weir. And we also have this equation for getting the time for a unsteady flow weir. So, for unsteady flow weir, having a cross-section na varying, this equation na nakita natin sa orifice will also be used in this problem. So, we have ASDH divided by the Q out, na integral ng H1 to H2. Yan. What if constant yung cross-sectional area natin? So, we have this derived equation for the time. That is equal to 2AS divided by CWL, then multiply to 1 divided by square root ng H2 minus 1 over square root ng H2. So, these are the equations to be used under this topic na weirs. Mahaba-haba. So, katulad ng sinabi ko sa orifice, na yung mga formula na to sa weirs, kailangan kabisado nyo sila kasi favorite topic ito sa hydraulics. Diyan umiikot yung mga tanong. So, weirs and orifice. Okay? So, itry natin magsagot ng mga problems na gagamit nitong formula. A rectangular sharp-crested weir, 15 meter long, with end contraction suppressed, is 1.5 meter high. Determine the discharge when the head is 300 millimeter. So, from the problem, we have a suppressed weir. Ayan o. End contraction suppressed. So, kapag suppressed, full width na weir yan. Walang contractions, walang contractions. Given tayo ng head ng water na 300 millimeter, and we have this height ng weir, given din na 1.5 meters. So, yung head natin 300 millimeter. Then, this would be our length. The length is given 15 meters. Yeah. So, we are asked to solve for the discharge. Ayan. So in this problem, discharge yung pinapahanap. Eh, di ba, meron tayong dalawang equation for the discharge. That is, Q is equal to CW L H plus HV raised to 3 halves. Ayan, then plus HV raised to 3 halves. So, check ko nga kung kabisado ko pa talaga to. Ito ba talaga yung formula natin?
But yung may on and
Yung sa may, ayun, no, minus daw yon. Sabi na minus yun eh. Ayan. So, this is minus. So, for Q to na considering head approach. Ayan. Yun yung Q natin ng considering approach. Whereas kapag ka neglecting approach, yung mas maliit.
pag nilike yun.
Ayan. Ano? So, neglecting approach, that is only Q is equal to CWL H raised to 3 halves. Yan, yan yung value natin ng Q. Now, for CW, di natin alam kung ano yung gagamitin. Ayan. So, binanggit ba na considering or neglecting approach? O, pag hindi binanggit, neglecting na agad yan. Yan. Then, for the value of CW, we have a lot of equation for CW. Diba? We have there for the standard na Weir factor, that is CW is equal to 2/3 ng C square root ng 2G. Ayan. And we have Francis formula. Tapos yung Rebac and Chow. And we also have the Basin's formula. So, in this problem, hindi binigay yung C. So, meaning, hindi natin magagamit tong standard. Ayan. O, hindi rin binanggit kung kaninong pangalan or kung kaninong Weir factor yung susundin natin. So, for this type ng problem, ang gagamitin mo agad is the Francis formula. Na pag hindi binigay yung C, tapos walang binigay na pangalan ng creator ng formula, so Francis na agad. Okay? But for our Francis formula, 'di ba, meron tayong dalawang equation diyan. And we have to check for the ratio of H over P. No? Kailangan less than sa 0.4 para magamit mo yung CW na maikli. Pero pag nag-greater than, kailangan yung mahaba. Ayan. So, sige, check muna natin si H over P. Tingnan natin kung ano yung gagamitin natin value ng CW. So, sabi for the H over P, that is equal to the head na 0.3 divided by 1.5. Solving for H over P, yan ay 0.2, which is less than 0.4. Meaning, yung CW na gagamitin is 1.84. So, substitute natin kang 1.84 sa equation natin for Q na neglecting the approach. Ayan. So, Q would be 1.84 LH 3 halves. So, actually, this equation is the Q for neglecting approach and using the CW na for less than ng 0.4 yung ratio ng H over P. Ayan na agad yun. So, lagyan natin ng value si L and si H. Okay, L ay 15 and yung H naman is 0.3. So, solve natin agad si Q. So, Q is equal to 1.84, L 15, H 0.3 raised to 3 halves. Simplifying, we have our value of Q na 4.535 cubic meter per second. So, this would be our answer for problem number 10.
Yan. Papansin na yung
So again, kapag hindi binanggit sa problem kung neglecting approach or considering approach, neglect agad yun. Then kung hindi rin binanggit kung ah, kung anong formula yung gagamitin, Francis na agad. Also kapag hindi given yung coefficient of discharge. Basta, you have to check for the ratio ng H over P. Para malaman mo kung anong equation ng Francis formula yung gagamitin.
Gagawa namin.
Yeah, so let's proceed to problem number 11. So as you can see on the figure, we have a weir na contracted yung both sides niya or doubly contracted. A rectangular sharp-crested weir with end contractions is 14-meter long. How high should it be placed in a channel to maintain an upstream depth of 2.35 meters for flow of 400 liter per second? Use Francis formula. Yan, so binanggit na, no? Use Francis formula. But again, alin doon? Yung greater than h over p ba? Or yung h over p is greater than 0.4 or yung less than 0.4? Hindi natin alam. No? So, i-check natin. May value ba tayo ni h? So, by reading the problem, we don't have value of h na binigay. And wala din tayong binigay na value ng p. So, paano natin ma-check kung anong equation ng Francis formula yung gagamitin? Ang binigay sa atin is the total depth ng upstream, which is the addition ng H and P. Ayan. So, ito daw yung kailangan nating i-maintain na depth by this flow na 400 liters per second. Okay. So, we have given Q. Q is 400 liter per second. Or, in cubic meter per second, that is 0.4. Yeah, 0.4 cubic meter per second. Ayan. So, going back, we have to use for the Francis formula. Since we don't have H and P, we can assume that H and P, the ratio of H and P is less than 0.4. So, assume natin na ganon. We will use the CW of 1.84. Ayan. So, assume muna natin na magiging less than. Then, after using this value of CW for the Q, na neglecting the approach, which is Q is equal to CW LH 3 halves. After using this CW na 1.84 and verifying the value of H and value of P using this given na 2.35, ma-check mo doon na kung less than ba talaga or greater than. Now, kapag na-greater than 0.4, you have to go back to the first equation. Napapalitan mo yung CW. Use the longer value of CW of Francis formula. Yan. Pero pag okay naman, kapag naging less than, goods na yon. Okay na yung nasolve mong value ng P and H. Okay? So, let's substitute this 1.84 to this equation ng Q, neglecting the approach. We have 1.84 LH 3 halves. Ayan. So, we have a contracted na weir, double contracted weir. And sabi natin, kapag double contracted weir, the effective length must be solved using the equation of 1.4 minus 0.1 and H. Ayan. So, yung first problem natin kanina, that is a suppressed weir. So, we don't have to manipulate the effective length of the weir. Yun na siya agad. But here, we have a rectangular na weir. So, kailangan pa nating baguhin yung effective length niya. So, the effective length is equal to the 1.4 minus 0.1 NH. So, since doubly contracted yan, or end contractions, no, ayan. So, doubly, we have a value of 2 in our H. And or value of 2 sa N. And then yung H naman, di natin alam. Okay, so simplify na lang natin tong L in terms of the H. We have 1.4 minus 0.2H. And then substitute this value of L sa equation ng Q Now, we have 0.4 equal to 1.84 times 1.4 minus 0.2h multiplied to h raised to 3 halves. Now, in this equation, we have the only unknown na h. So, we can directly solve for the head of water in our weir. So, that value is 0.297 meters. So, we can solve for P by this given depth of upstream na 2.35. So, D is equal to H over H plus P or 2.35 is equal to 0.297 plus P. Solving for P, that is 2.053 meters. Now, you have the value of H and P. Mache-check mo na ngayon yung ratio mo ng H over P kung less than ba yan or greater than 0.4. Sige nga, pakicheck kung ano yung value ng ratio ng H and P natin. 0.297 divided by 2.053. So, what would be the value of our H over P? Ayan. 0.145. So, yan yung na-calculate yung value ng ratio natin. So, this value ng ratio ng H over P is less than 0.4. Meaning, yung mga values ng H and P natin na solve is okay. Ayan. So, ano ba ang tanong? Ang tanong is, how high should it be placed in a channel to maintain an upstream of depth na 2.35? So, the height of our weir is P. So, the answer is 2.053 meters. So, ganun yung pag-check. Kapag naging greater than, babalik ka sa pag-solve mo ng Q, wherein CW is not equal to 1.84, no, yung mas mahabang equation. More problems ba? Ayan, no. Problem number 12 tayo. So, during a test on a 2.4 meter suppressed weir 900 millimeter high, the head was maintained constant at 300 millimeters. So, in 38 seconds, 28,800 liters of water were collected. So, what is the weir factor CW? Consider the velocity of approach. Ayan. So, ang pinapahanap sa atin is CW and we have to consider the velocity of approach in our equation of Q, flow rate. Ayan. So, we have a suppressed weir, suppressed full width na rectangular weir. Ayan. So, may height yan na 900 millimeter and may length na 2.4. Then, the head of water is given na 300 millimeters. So, lagay lang natin dito yung mga given. Ayan. So, for this velocity of approach, para may consider natin siya in our equation, we will use this equation na CWL multiply to H plus HV raised to 3 halves minus HV raised to 3 halves. Ayan. So, for this equation, do we have the value of Q given in our problem? Yes, we have. No? But, kailangan pa natin siyang isolve. Yung magbibigay sa atin ng Q dito is yung time na 38 seconds and the volume that is collected. No, volume in terms of liters. So, remember that Q is equal to the volume divided by the time. And our volume here is 28,800 and the time naman is 38. So, dividing these two values, we have 757.895 liter per second na Q. Ayan. So, we have to convert this liters per second into cubic meter per second. Kasi sa equation natin ng Q, no, dapat nasa cubic meter yan per second. So we have to divide it by 1,000 para maging cubic meter per second. So divide natin, we will have Q na 0.758 cubic meter per second. So let's store that value at our calculators. Ayan. So, lagay natin si Q. So, we have 0.758 na. Si CW, hinahanap. Kasi, what is the Weir factor? So, hindi natin alam yung value ni CW. L. L is given. That is 2.4 meters. Kailangan pa bang baguhin using the equation na L is equal to 1.4 minus 0.1 NH? Kailangan pa ba itong equation na to? Hindi na, because that is suppressed weir. Yung mga binabago lang natin na length ay contracted weirs. Ayan. So, L natin ay 2.4 na agad. Okay? Then, we have this quantity. Yeah? And yung H natin, that is the head of our liquid from the water surface hanggang sa top ng ating weir. That is 0.3. Ayan. Then, for HB, HB, this is the head, velocity head of approach. Ayan. So, paano natin makukuha yung velocity head of approach? So, parang sa pagkuha lang ulit natin ng velocity head, no? That is equal to the v squared over 2g. Pero, yung velocity mo, dapat yung velocity sa approach. Na yung bago ka magkaroon ng weir. Ayan. So, drawing natin ulit na yung natin, yung nasa side view. So, let's say we have our channel bed dyan, nas andito yung weir natin. So, at this point, stable yung liquid natin, wala nang pagbaba na nangyayari. So, stable yan dyan. Then, pag dumating na tayo sa weir, magkakaroon ng drawdown. Tapos, magpo-flow na yan dyan pababa. Ayan. Then, andito yung water level natin at the downstream. Ayan. So, yung approach natin is yung kompleto pa, di ba? Yung we have the head na mataas hanggang dito. We have D. Ayan. So, for us to get the velocity of approach, gagamitin lang natin si Q over area kung saan wala pang weir. So, that is the total D, yung H plus P. Diba? So, A natin is D times the length of the weir na 2.4. Yung Q nakuha natin, that is 0.758. So, 0.758 divided by area. Yung D, ano ba yung D natin? That is H plus P, which is 0.3 plus 0.9. So, 1.2. Diba? Then, yung L naman natin, given 2.4. Yan yung ating velocity of approach. So, it happens bago magkaroon ng weir. So, let's substitute this value of BA sa equation natin for the velocity head of approach. So, we have 0.758 divided by 1.2 times 2.4 squared divided by 2g. G is 9.81. So, simplifying for the velocity head of approach, we have 3.530 times 10 raised to negative 3 in meters. Kasi head yan. Ayan. 3.530 times 10 raised to negative 3 meters. So, we will substitute this value of HB dito sa equation natin for the Q. And to solve CW. So, we have HB 3.5 3 times 10 raised to negative 3, no? Raised to 3 halves, yung lahat, yung H plus HB yung naka-raise, no? Hindi isa lang. Then, minus HB raised to 3 halves. So, yun, 3.53 times 10 raised to negative 3 raised to 3 halves. So, simplifying this equation and solving for CW, we have CW na 1.891. So, this would be our answer for number 12. So, although this constant na wear factor, contributes to the unit ng Q natin for the Q. So, dito, pag sinasolve natin siya, wala pa rin siyang unit kasi nga factor lang siya. So, CW is equal to 1.891. So, those are the sample problems for a rectangular weir. So, let's proceed to a triangular weir naman. So, determine the discharge of a 90-degree triangular weir having a head of 0.3 meters in liter per second. So, actually, in this problem, we don't have the figure. Ayan, so, lumabas na talaga siya dyan. Hindi talaga binibigay, ito lang, yung determine the discharge of the 90-degree triangular weir. Kasi kaya naman natin itong i-imagine eh. Yeah. So, 90-degree weir, ito yon yung angle na yon yung nasa gitna. And the head is measured from the water level hanggang sa crest. Yeah, so 0.3 meters. So, for a 90-degree triangular weir, if we will go back to our cheat sheet, ayan, yung formula sheet natin. So, for a triangular weir na 90 degrees, ito yung gagamitin nyo equation, SI. 1.4 H raised to 5 halves. Ayan. No, hindi na ito kasi 90 degree. So, ito na yung na-derive. 1.4 H 5 halves. So, let's use that equation. Ang kulang lang natin dito para ma-solve si Q is yung H. Eh, yung H given na agad eh, 0.3 meters. So, let's substitute this 0.3 meters to our Q. We will have 1.4 times 0.3 raised to 5 halves. Multiply. So, we have Q na equal sa 0.069 cubic meter per seconds. But we have to solve for the discharge na in liters per second. So, we have to multiply this by 1,000 liter per cubic meter. So, our final answer for this problem number 13 is 69.013 liter per seconds. Ayan. So, kapag ganyan yung problem, no? Compute for the 90-degree triangular weir, yan, pwede nyo magamit yung derived na equation na agad. 1.4 h raised to 5 halves. Problem number 13.
Hindi. Oo, tama. I-let mo na yung lahat to. Oo, yun to. Tapos, ayun, derivative mo. Tapos may matitira ka nung ano, x. Ay, e raised to x dx yun. Negative 7 e raised to x dx. Hindi pa raised to negative x. Ha? Plus 1. Ba x? Ano derivative ng e raised to x? Negative x. Hmm? Ito? Ano siya?
Ayan, sige. So, let's have a problem naman na about a triangular or trapezoidal weir. Ang given sa atin to. Labas ko lang. So, a trapezoidal weir having side slope of 1 horizontal to 3 vertical discharges 50 cubic meter per second under a head of 2 meters. We have this 2 meters na head. So, ito yung Q na 50 cubic meter per seconds. Then, find the length of the weir, assuming C is 0.6. So, ito yung length na hinahanap, yung length ng crest natin. So, how are we going to solve for this Q or this L? Ayan. So, pwede natin gamitin yung mga equation natin for Q wherein that is just the summation ng Q for a rectangular plus Q of a triangular. So, sulat natin, we have Q is equal to CWLH 3 halves, then plus CW2. So, ito, W1 to. Then, we have ZH raised to 5 halves. Ayan. Then, luckily, we have this given C na coefficient of discharge. Then, we know that the CW1 is for a rectangular which has this equation na 2/3 C square root ng 2G. Then, yung CW2 naman, that is 8/15. C square root ng 2G. Then, this Z naman is equal to the tangent theta over 2. So, tangent theta over 2, dapat nandito yung parenthesis niyan. Ayan. So, equal yan kay Z. And also, we know that is equal to B over H. Now, given yung side slope ng ating trapezoidal weir, yung sides niya. So, we have 1 and 3. 1 horizontal, 3 vertical. Pwede natin magamit itong ratio na yan to solve for Z dito sa ating equation or this tangent theta over 2 or this BH. So, yung B natin, pwedeng yun yung 1. And yung H naman, that is the 3, no, using this proportion. So, we have tangent theta over 2 is equal to 1/3 din. Ayan. So, substituting the value of CW1 dyan sa equation natin and CW2 and Z na tangent theta, ang mangyayari sa equation natin is hahaba siya ng ganyan. So, we have 2/3 square root ng 2G, CLH 3 halves, plus 8/15 square root ng 2G, C tangent theta over 2, H 5 halves. So, Q is 50 equal to 2/3 square root ng 2G. So, 2 times 9.81. C is given 0.6. L, unknown. That is this L. H naman is the head of our liquid hanggang sa crest. That is 2 meters. Raised to 3 halves for this rectangular. Then sa triangular, we have 8/15 square root ng 2G. C is 0.6 pa rin. Then the tangent theta over 2 is equal to 1/3. Ayan. L, 2 pa rin. Raised to 5 halves. Diba? So, in this equation, the only unknown is L, and we can directly solve that. And the value is 9.444 meters. So, this would be the answer for problem number 14. Okay, so let's proceed. So, second to the last problem for this day. Problem number 15. So, the discharge over a trapezoidal weir is 1.315 cubic meter per second. The crest length is 2 meters and the sides are inclined at 75 degree, 57 minutes and 49 seconds with the horizontal. Find the head on the weir in meters. Ano daw yung head? Ayan. So, yung head na ito yung hinahanap natin. So, we have the trapezoidal weir and we have yung length. Length is 2 meters. And going back to the problem, we have this sides na angle of the sides na 75 degree, 57 minutes, and 49 seconds. So, that is located here. No? Kasi naka-measure daw siya with the horizontal. So, ito yan. And that angle, yan yung angle, kilala natin to. Kapag nakita tayong gantong angle, alam na yan agad. That is for a Cipolleti weir, which has the side slope na 1 horizontal, 4 vertical. Ayan. So, for the Q of a Cipolleti weir, Q natin dyan is equal to 1.859 LH 3 halves. 1.859 LH 3 halves. Then, here's the equation natin. We have Q. No, given sa problem natin yung Q, that is 1.315. So, substitute. We have 1.315 equal to 1.859. So, take note, 59, may 5 pa dyan. 1.859 times the L. L is 2 meters, no, the crest length. So, times 2 times h raised to 3 halves. Now, h natin is yung unknown sa ating problem. So, solving for h here is 0.5 meters. So, ayan, directly nasa-solve lang siya using the equations natin. Empirical equations.
Ano mo dapat yun, yung mga kalimutan yung problem. Diba yan? Ito yun, 44, 5,
Okay? Ayan. So, last problem, problem number 16. A rectangular suppressed weir of length 1 meter is constructed or cut at the top of a tall rectangular tank having a horizontal section 20 meters by 20 meters. If the initial head over the weir is 1 meter, compute the time required to discharge 72 cubic meter of water. Use Francis formula where H over P is less than 0.4. Ayan, so binigyan na tayo. CW natin kapag ganyang condition ay 1.84 na agad. Ayan. So, initially, yung rectangular tank natin, no, rectangular talaga siya. Ayan, so, yan, straight to dapat, no, initially. And this is our head. Now, siguro, no, na-board yung may-ari ng tank, no, kinat niya yung part ng tank and nagkaroon siya ng weir, suppressed weir. So, the head initially is 1 meter. 1 meter, the dimension of this tank is 20 meter by 20 meter. Horizontal na cross-section. Ito yon yung part na yan. Okay? Oops. Meter. Now, hinahanap sa atin is yung time, no, required kapag nakapag-withdraw tayo ng 72 cubic meter of water. Yun yung volume natin na required. So, how are we going to solve for the time? And so, let's go back to our formula sheet. Formula sheet natin. We have this equation for calculating the time. Natin. So, 4. the unsteady flow, meaning we have varying head, no? Nagbabago yung head natin. So, dito, ayan siya. So, we have this two equations. So, isa yung integral, no, for the varying cross-section. Ito namang isa for a constant cross-section. So, alin kaya dito yung gagamitin natin? So, as we go down doon sa liquid natin inside the tank, habang nagwi-withdraw yan, yung cross-sectional area natin, constant lang, di ba? So, meaning, ang gagamitin na natin is ito, equation for the time. So, solve natin, di ba? Yung nagwi-withdraw dito is hindi naman nagbabago. So, ito yung gamitin natin. We have T is equal to AS T is equal to 2AS CWL times 1 over square root ng H2 minus 1 over square root ng H1. So, tingnan natin kung ano yung mga value na meron tayo. So, CW meron tayo. Time, wala. Yun yung hinahanap. AS, yan naman, meron naman tayo ditong equation for the area. And, do we have H2? Yung final head natin. Ayan. So, wala tayong final head na given, but meron tayong binigay na volume na na-discharge. So, pwedeng yun yung pwedeng magamit natin yun to solve for the H2. Okay? Then, H1 naman, meron tayo yung initial head that is 1 meter. So, 1 meter. So, let's solve for AS. So, solve natin yung value ni AS. AS ay 20 by 20 or 400 square meter. Then, yung length naman, dito, length na solve natin, that is 1 meter naman, or nandito pala yan sa problem natin, that is given. And so, pressed weir of length 1 meter. So, let's solve for the value of H2. Kasi kailangan natin siya eh. Paano natin siya makukuha? Gamitin natin yung drop of water level after discharging 72 cubic meters. So, we can use this equation ng volume relating the cross-sectional area times the height. Diba? Times the height, which is V is equal to ASH. So, 72 is the volume withdrawn. Then, AS is yung 400 square meter. Then, H naman, yun yung height na dinrap ng water natin. Yun yung dinrap or pagbaba sa atin. So, solving for H, that is 0.18 meters. Ayan. So, ito bang 0.18 meters? Yun ba yung bago nating head? Hindi. Kasi itong 0.18, yan yung ibinaba. So, from this level, bumaba siya ng 0.18. 0.18. Yan yon. Hindi yan yung head natin. Di ba? Ang head, laging sinusukat from the water level hanggang sa crest ng weirs natin. So, you have to solve for this distance. Paano naman yun isa-solve? Ayan. So, using this initial head na 1 meter, minus mo lang yung binaba. So, 1 minus 0.18, that is H2 na 0.82 meters. So, using the equation for time, that is 2AS, CWL, 1 over square root ng 2 minus 1 over square root ng 1. So, we have 2 times 400 divided by 1.84 times L na 1 times 1 over square root ng 0.82 minus 1 over square root ng 1. Ayan, nauna na lumabas yung sagot. So, simplifying, the time is 45.354 seconds. Ayan yung time para makapag-discharge yung tank natin or yung weir by 72 cubic meter of water. So, by 45.354 seconds, no, mawi-withdraw natin si 72 cubic meter. Ayan. So, that is all for our weir discussion. Okay, so for your activity, we'll be having our plate number 3. So from the pitot tube hanggang weirs. Now, this activity will have a due na 2 weeks. Ayan. So, 2 weeks nyo pwedeng sagutan yung activity na yun. So, pwede naman nang magpasa kayo if tapos na. Ano, halimbawa, later, kung may time kayo, tapos natapos nyo agad yung problem, pwede nyo na siyang ipasa. Ayan. So, pwede rin naman antayin yung deadline para sipagin. Pero, I suggest guys, na kapag binigay na sa inyo yung mga problem, sagutan nyo na agad para di kayo natatambakan. Ayan. So, ayun. Overall, ang pinakakailangan natin sa session natin today about orifice and weir ay magkabisado ng formulas. Ayan. So, kung nag-iipon na kayo ng index card ninyo na may mga nakalistang equations, ayan. So, marami kayong may dadagdag ngayon. Okay? Ayan. So, do you have any question ba about weirs?